Part 1, Architectural Plans. Good day. This is Vimo Construction and Supply presenting to you our architectural plans of our proposed four-story steel commercial building. So, this is our perspective for the front elevation and for the side elevation. Next is yung sa vicinity map. So, sa vicinity map is dino namin kung ano lang yung nakita namin sa Google Map. So, ito yung screenshot sa Google Map. Sabi niya dito, um, the location is in San Miguel, Camp 4, Tagum City, Davao del Norte. But if you'd like to visit it sa Google Map, ito yung Google Map link na provide namin below. So, ito. Next, for the site development plan is, sabi niya dito, the floor area is 1,075 square meters, which is 28 by 40 minus 9 by 5. So, that is that a total of 1,075 square meters. For the site area is 4,800 square meters, which is 60 by 80 yung ano, dimensions niya sa property line niya. Next, for the ground floor plan, this is our supermarket, and then yung staircase namin, first staircase, and yung second staircase, and then first elevator, and then yung second elevator namin, and for the fire exit. So, may mechanical and electrical room, utility and storage room, common toilet rooms, rentable spaces, and then hallway, and then lobby, rentable spaces again, and for the entertainment hall. Next is for the second floor plan. Second floor plan, um, may department store kami sa itaas sa second floor, which is uh, also, which is may ano din kami, utility and storage room, rentable spaces, food court and food stalls, dalawang elevator again, dalawang staircase, tapos yung common toilet room, which is yung female comfort room and then male comfort room. So, ito rin yung fire exit. So, may fire exit lahat ng floor levels. So, next is third to fourth floor plan. So, dito, may rentable office kami. So, ito yung mga rentable offices namin. Dalawang elevator, dalawang staircase, and then yung dalawang toilet room for female and male. Common toilet rooms. So, may sarili din silang toilet rooms or comfort rooms, which is nandito. Makikita siya sa every rentable office floor area. So, for the roof deck, so ito yung location ng dalawang big tanks namin na kaya makaprovide ng sanitary and drinking water sa whole building. And then, dito yun ang opening para sa aming roof deck, which is ito yung staircase namin, and then for the fire exit. So, makikita dito sa front elevations namin. So, ito, yung front elevations namin with a height of 0.5 from natural grade line to first floor line. Then, 3.6 para sa next na second floor line. And then, the third floor line is 3.2, 3.2, and then 3.2. Next, ito yung sa rear elevation. So, this is for para sa supermarket namin. So, kaya may ganyan. And then, ito yung sa utility room and mechanical and electrical rooms. So, for the left elevation, so, ito yung sa left elevations namin. And for the right elevation. So, dito sa right elevations, makikita yung location ng aming fire exit, or nandito siya kung titingnan natin sa front elevation, nandito yung fire exit namin. So, for the schedules of doors and windows, so, may 74 sets siya sa door 1. For door 2 is 5 sets only. Door 3 is 15 sets. Door 4 have 16 sets also. For the D5 is 2 sets. For the for W1, so 22 sets. W2, number of sets is are 144 sets. W3 is 8 sets. W4 is 32 sets. W5 is 12 sets. W6 is 60 sets. So, ito lang. I think. Thank you. Part 2, structural analysis. For the structural analysis, we use STAD application. But before that, we should identify first the loadings. And so, this part is for the load calculations for our STAD application. So, first is we identify the earthquake load. So, for the earthquake load, these parameters are all can be seen sa NSAP 2015 or are all stated. These are from the provisions from NSAP 2015. So, which yung importance factor is I is equals to 1, zone factors is equals to 0.4, R is equals to 8, soil profile type D, SD, soil seismic source type A, NA and V is equals to 1, and then CA and CV is equals to 0.44 and 0.64. So, ito yung mga tables na makikita sa NSCP 2015. So, ito yung table para sa NA, table para sa NV, table para sa CA, table sa CV, and then yung table para sa seismic importance factors. Next, for the dead load, we use 23.54 kilonewton per cubic meter para sa concrete na factor for our dead loads. And then masonry, concrete for walls is 21.2. Then floor finish or quarry tile is 1.1 kilopascal. Then plaster on tile or concrete is 0.94 kilopascal. Factor full grout is 2.97 kilonewton per square meter. So these all parameters or factors are in NSCP 2015. So for solving the exterior wall or the member load sa mga exterior walls, um, ang nakuha namin na member load is 10.694 kilonewton per meter para sa second to fourth floor because we use 0.15 thickness ng wall kasi mas thick yung ginamit namin para sa outer walls. And then for the outer wall ng roof deck is, ang yung ginamit namin na thickness of wall is 0.1 since wala naman masyadong mga tao doon. Hindi naman siya masyado ginagamit yung roof deck. So that's why 0.1 lang yung member load namin. For the interior load is lahat ng interior load is ginawa namin 0.1 yung wall ng thickness. That's why yung member load namin for the interior walls are 7.129 and 6.069. 10.694 naman para sa mga lahat ng outer walls except for the roof deck from second to fourth floor yung ginawa naming 10.694 and then para sa roof deck is 6.069. For the floor load para sa second to fourth floor is 4.874 since yung thickness ng slab na ginamit namin is 0.15. And for the slab sa roof deck is only 0.125 since wala naman masyadong loadings doon kasi nga hindi naman masyadong ginagamit yung roof deck. So after na yan po sir is by the way, so lahat ng mga parameters na makikita dito is are all in NSCP 2010. So ito yung mga tables niya. So for the load calculation sa live load is ito yung mga values for the rentable space and stores which is 2.4 and then lobby to 4.8, comfort room 2.4, hallway 4.8. So ito yung load calculations or live load calculations sa ground floor kasi These are all written sa NSCP 2015 kung ano yung mga live load values para sa mga floor loads. So, for the second floor, since ang nandun sa second floor is rentable spaces and stores which is 4.8, then comfort room 2.4, and then the hallway 4.8. For the third to fourth floor, ang yung office live load na ginamit namin is 2.9, 2.4, 4.8. And for the roof deck is 1.9 all lang siya. So, ito yung mga guide namin kung saan namin kinuha yung mga values sa para sa aming loading sa live load. So, these are all in NSCP 2015. For the fluid load, so ito yung solution kung paano siya kinuha. So, first, dapat kasi sabi sa syllabus that the building should have two big tanks na makaya niya na produsan og sanitary water and drinking water ang for multi-story commercial building. So that is why we used 2 meters for the diameter and 3.5 meters for the height. So ito yung design namin, water tank design namin. So since dalawa yung kailangan, so each each floor load is 4.4657 sa dalawang floors na lalagyan ng din sa dalawang tank na ilalagay sa roof deck. So ito yung so ipapakita ko sa staad kung ano yung mga loading. So first is let's start with the dead load. Para sa dead load is ito yung para sa mga floor load, if may one, meaning one way slab siya, if so, kung makikita mo dito, 4.874 from second to fourth floor, since yung ginamit namin dito is 0.15 ang thickness ng slab. And for the roof deck is only 0.1, that is why yung value ng roof deck is 4.285 lang kung compare sa second to fourth floor. May mga one way po, dito po makikita yun sa my stairs. So, next is for the seismic. Next is for the next is yung mga member loads. Yung sa member loads is 0.15 sa lahat ng member loads sa lahat ng members ng mga outer walls. So, yung sa lahat dito, yung mga outer, lahat ng member loads dyan is lahat ng loads dyan is 10.694. So, for the inner is only 7.129 since I only use 0.1 for the thickness and 10.694 naman yung thickness para sa outer. And then, ito yung sa thickness na 0.1 para sa roof deck and also for the roof deck also. So, at saka last yung sa self-weight. Next, para sa ginamit namin seismic definition is ito yung mga values ng seismic definitions. So, yan, RA 1181 and 1.2. For the ELX is 1 and then EL2, ELX negative, ELZ positive, ELZ negative. And for the dead load is reference load lang yung ginamit and negative 1 since positive yung ginamit dito. So, lahat ng mga loads na i-apply dito sa live load and fluid load are all in negative. So, for the live load is negative 6. So, ito yun. Second. The part 2, which is the step-by-step procedure for the structural analysis. So first, here's the analytical modeling or the geometry of our first four-story commercial building. Um, so for our properties, we use 14 by 370 for the columns, 14 by 100 for the second floor, 12 by 87 for third floor, 12 by 65 for fourth floor, and 12 by 45 for the roof deck and the floor beams. So for our plates, um, this plate is made of concrete, and then this is for para sa staircase. So so yan po sir. So all steel na ginamit namin po sir is 50 KSI. For the specification, um, so dito sa specification, selected objects. So dito makikita yung mga beams, floor beams namin na nirelease namin. So ito, floor beam para sa elevator and then floor beam para sa staircase. So naka-release yan sila, yung mga floor beams. For dito din, display hall structure, and then dito din, selected objects. So ito po sir, naka-release yung mga floor beams sa elevator and then sa staircase. So may for the diaphragm is we use 3.6 for the second floor, and then 3.6 plus 3.2, which is 6.8 para sa third floor, and then para sa fourth floor is 6.8 plus 3.2 is equals to 10 meters, and then 13.2 para sa roof deck. So ito po yung diameter niya. Diaphragm, I mean. So next is sa supports po sir is we use pin connections since we assume that yung columns is not perfectly fixed pagka pagka connect po sa base plate or sa pedestal and or sa support niya sir. So that's why we use pin kaya dili siya perfectly connect or perfectly fixed. So for the loading is reference load definition for dead loads. So view selected objects. So one way and then two way, one way. So itong 4.874 is nasa computation of loads namin po yan sir. So ito lahat is yung mga floor loads namin is nasa computation of loads. So makikita mo dito po sa floor na to sa stairs is one way load po siya ay one way po siya sir, and others yung two way na yung iba. And then for the member load, yung computation nito po sir is nasa computation of loads. Tapos yung sa member loads po sir, ito yung ginamit namin para sa outer walls, which is I think 0.15 yung wall thickness. And then para sa inner walls, which is 0.1. And then for the roof deck, which is I think point 1 also. So tapos dira sir kay para sa katong pasaka dito sa para nalay magtabon para sa walls sa staircase padulong sa roof deck sir. So ito self-weight niya po sir. And then for the seismic definition, UBC, we use UBC 1997. Reference load wise, so dito is 0.4 yung zone, importance factor 1, RW8, RWZ is 8 also. So profile type is 3, NA 1, and then NV is 1.2. For the load cases, so for the load cases, sir, is my ELX, and then so ito, so positive X, negative X, positive Z, negative Z. So ito yung mga details niya po, sir, which is um, 0.5 yung multiplying factor for accidental torsion moment, and then 1 para sa natural torsion moment. So for that, so same lang yan sila sir, nagvary lang sa kung anong direction at kung naka-positive siya or negative. So along z-axis pa siya or along x-axis. So para sa dead load is since nandito naman siya sa reference load definition, so negative 1 dito kasi positive 1 yung nilagay dito po sir. So positive sila lahat yung mga loads po dito. So negative 1 dito sir. And then for the live loads is nasa computation of loads po yan sir, which is ito yun. So selected objects. Ito yung sa um, live load 6 4.8 para sa hallway hallway dito po yun sir is hallway po na live load para lang sa stairs, tapos ito live load po na hallway, and then CR, which is the common toilet room. So itong sa 4.8 is included na po yun dito yung mga rentable spaces. So for the third floor is ito yung sa mga rentable offices, which is according sa NSCP po sir is 2.9 po para sa mga rentable offices, 4.8 para sa yung sa utility and storage room, and then dito po sir is para sa hallway, and then hallway po na one-way load, which is para sa mga stairs. And then ito yung sa common toilet room, which is 2.4. So lahat ng po ito sir is makikita po sa computation of loads namin sir. So for the fourth floor, ito. Ito. Selected objects. So for the fourth floor is 2.9 para sa mga rentable office again, for 4.8 para sa storage room and utility room, and then 4.8 para sa hallway, and hallway na po para sa one-way load, one way po lang po na floor. And then negative 2.4 para po sa common toilet room. For the RD or the roof deck is display hall structure. Hello? No problem. Hello? So next live load niyo po sir is yung sa roof deck na live load. So para sa roof deck na live load is isolate muna natin yung sa roof deck. So ito yung makikita sa roof deck. And isang one-way slab na 1.9. So negative, lahat sila ay negative 1.9 yung live load na sa roof deck. So para sa fluid load is, yung gamit namin po sir is 4.467 para sa isang floor area or isa sa isang base. So for another 4.467 para sa another water tank na naman po sir. So for our NSCP, by the way, before that sir, so again, let's see if kung ano yung mga loading diagrams ng lahat ng mga primary load cases. So for the earthquake load, X positive, so ito yung orientation niya sir. Ito ang orientation ng earthquake load positive, X positive. For the earthquake load, X negative. And then, earthquake load, Z positive. Ito yung sa earthquake load, Z negative. For the dead load is, dito yung sa floor loads, member loads, and yung self-weight niya. And for the live loads is, ito yung mga different live loads ng mga supermarkets, rentable offices, rentable spaces, yung hallway, and yung sa roof deck na live load, so etc. So nandun na yung dito yun sir, makikita dito sa mga floor loads na to. And then lastly, sa fluid loads, located sila sa roof deck, which is 4.467, negative 4.467. So para sa load combi na ginamit namin po sir is according to sa NSCP, which is according to NSCP 2015, load combinations using strength design or load and resistance factor design or LRFD. Ito yung mga formulas niya sir. So 1.4 plus, so ito lahat sa 203.3.1, the basic load combinations. So ito yung mga LRFD combinations. So finalo lang po namin sa NSCP 2015. And then next po sir is yung sa load combinations using allowable stress or allowable strength design or DASD. So D plus F, so ito lahat is makikita po ito sa aming load combinations. And then lastly po na ginamit namin is yung sa alternate basic load combinations. So sila tatlo, the basic load combinations using LRFD and using ASD. And then the other one is yung sa alternate basic load combinations. So dito po sir is itong sa LRFD, ito lahat yung sa LRFD hanggang dito sa from 8, load combi 8 hanggang sa load combi 19. And then next, para sa ASD na load combinations is from 20 up to 36. So, 20, I mean sir, 20 up to 20 up to 26 yung para sa ASD, and then ito yung sa basic load combinations from 27 to 36. Next po sir is para sa analysis is kinuha namin yung nag-perform analysis po kami sa mga seismic loads namin for, uh, along X positive, along X negative, along Z positive, and along Z negative. After namin po nakuha yung mga load combis namin, the primary loads and then the load combis, um, P delta analysis, small delta, and then after, itong sa story drift, sir. So, according sa NSCP, sir, is yung ginamit namin is ang formula ng story drift is which is 0 point r lambda s is equals to h over 4t. So, na-derive namin yung lambda s is equals to h over 224, which is yan yung allowable drift, which yung values niya po is 0.00446. So, ito na po siya, makikita po dito sa pin story drift. And then, for the checking for the LRFD, since gumamit kami ng NSCP 2015 for our load combister, so pag-check namin po para if nag-fail yung mga steel beams namin and steel columns, gumamit po kami ng ito AISC po yun na Unified 2010. So method LRFD FYLD is equals to 248,000 and then check code. I think that's all, sir. So but before that, sir, so let's check sa analysis output sa So, dito sa analysis output namin, sir, is yung sa story drift is lahat nag-pass along x-axis and then yung sa story drift along z-axis. Sa along x-axis is uh, to to para ma-sure, sir, na wala yung nag-fail is kina-search na mo. So, 0 matches yung sa fail. For the story drift along z-axis, 0 matches din siya, sir. So, walang nag-fail. So, for the steel design, wala ding nag-fail, sir. So, I think that's all, sir. But, before that, i-run na lang po, sir, para sure jud na 0 warnings and 0 errors. So, according po sa STAD analysis and design, 0 errors and 0 warnings po. And hindi pa pala tapos. Oh. Let's wait. Oh. 0 errors and 0 warnings po, sir. So, I think that's all for our presentation for the STAD analysis.
So, the design of beams. For the design of beams, ang una nga akong gibuhat is nag-tabulate ko og beam forces gikan sa staad. So see, for example kani So, mo niya siya mo ang structure sa taad after ma-run analysis. And kani siya is mo siya ang beam result. So, para matabulate ang forces sa beam is una na ko ang second floor. So, gi-display whole structure na ko siya. So, kuha na ko diri na part. Then, kani siya, mo na siya ang beams sa second floor, beams and floor beams. So, ang gibuhat na ko is i-tabulate na ko siya all the beams on horizontal and vertical. So, gi-copy ko lang result diri Then, gi-paste na ko siya sa ako ang gibuhat na tabulation. So, since second floor lang man to ako ang gikuhaan og beam results, so diri na ako gi-paste tanan. Ako ang nakuha gikan sa staad. Tapos, after siya ma-paste is, actually, tanan beams is ako ang gikuhaan og beam forces o ako ang tabulate, then gikuhan ako ang maximum moment, shear, and deflection kada beam. So, para sa ani si beam 2 to 9, so gikuhan ako yung maximum moment, then maximum shear, I mean this one shear, and this one is the deflection. So, kada isa ka beam is ikuhaan ako sila og ikuha na akong pinaka-max sa tanan kay since naka-by group namin sila dahil. So, after ma-tabulate isa-isa ang beam is nagkuha ko pinaka-max sa tanan, horizontally and vertical na beams. So, for the horizontal axis, ang max moment is kanyang 301.816. So, kana siya nga beam number is si beam 851. So, ang max moment is nabalong siya sa load combination na 13. 1.2 DL plus 1.0 ELZ. So, after na ko makuha so since sa vertical axis, ang max moment is si 204.731 and ang beam number niya is si 251. So, after makuha na ko si max moment is i-copy 851. So, wait. So, kuha na ko si 851 na. Actually, ako na lang siyang i-direct sa listaan. Isang kabalo ka ni si 851. So, kuha lang na ko ang yung values, tanan. Then, i-paste na ko diri sa tabulation. Kani siya nga tabulation, ikaduha nga tabulation is diri ato ma-solve isa-isa. Kung unsa tong pinaka-max, diri na ako gibutang para malahi siya sa katong uban beams. So, pag butang na ko diri since along horizontal man to siya, so diri na ako so, pag diri siya sa mo ni siya ang critical na beam section. So, after na, isikuhan na ko ang max moment niya, which is 244. Wait na. 244.916. Ang minimum niya is 158.266. Then, ang gamit niya na load combination is kang 0.9 DL plus 1.0 DLZ positive. So, kaning diri nga part is mo na siya tong moment. For example, 244.996 na. 244.996. 244.916. Dara. So, kani siya nga load combination. So, kani nga, kani nga, siya man ang max, so ang MA, ang MBNC na ko nga value is, gikan lang po siya, diri katong along length niya nga mga moment. Kung mao to siya, ang ako ang i-input, diri sa ako ang main na nga Excel, which is kaning second floor as building design. So, diri, ang gigamit na ko na section is katong gamit na mo diri sa staad. So, for the second floor, ang gi-assume na mo sa staad is 12 by 170 na section. So, butang na ko diri itong maximum moment nga nakuha na ko sa critical na beam from the second floor. Then, automatic na po siya nga mabutang dahil itong value sa MA, MB, and MC since naka-formula na siya diretsyo gikan sa iyang tabulation. So, ang gamit na ko diri sa akong beam design is 2010, 2015 na NECP code. So, ang LB na ko diri is 6 meters. Since 6 meters man itong critical nga beam length. So, for the analysis, as nadalong siya sa zone 2, which is the LP is less than LB and less than LR. So, after that, ano siya is masolve na niya diretsyo si MN, which is na safe man po siya. So, pwede siya gamiton na section for the second floor. So, pero ay nalimutan din ako. First tayo dapat is i-check tayo dapat first ang compactness section along. Dapat compact si flange and compact fold si web. So, dili ang section or dili ang portion kay magka-values lang ni sila if ang section sa flange kay non-compact or slender. So, since compact man ang section, so wala sila values. So, ang gibuhat na ko sa second floor tabulation is dili lang max moment ang gipapo na ko ang max shear and max deflection. So, kani siya max shear and max deflection kada isa ka beam. So, dapat katong napili na ko nga section is dapat safe pod siya sa maximum shear o maximum deflection. So, for the maximum shear is si 851 si 850 ang pinakadako og shear. So, kuha na ko yung values. Maximum shear is 325.342. And ano siya yung corresponding load combination. Then, i-design na ko siya diri. Gamit lang gihapon tong same beam section na gigamit sa max moment. Kung mag-safe ba gyapon siya sa maximum shear. So, na-find out man po na ang W10 by 170 is compact siya. Compact siya o safe siya gamiton for the maximum shear. So, ang so it means nga katong akong among gi-assume sa staad na section is safe siya or okay siya gamiton. So, inanay na akong gibuhat for the rest of the beam design for the third floor and fourth third floor to roof deck. So, gi-tabulate na ako every floor tanan beam. Hindi ko na akong maximum shear, um, maximum moment, maximum deflection. O try na ko o or test kung nakuha na mo na itong gyasyon na mo na beam section sa staad kung mo fail siya or mo pasar. Since so far ang section na gyasyon sa staad is safe man po siya sa Excel or okay siya sa na-check siya sa Excel na safe. So, okay siya. So,
So for the column analysis, need yung tabulation na makukuha sa STAAD. So first is makukuha itong mga values na ito sa post-processing sa STAAD, which is makakuha ka ng value ng fx, fy, fz, mx, my, and mz. Since we are dealing sa columns, so we will only use fy, mx, and mz. So every column members, itong lahat na column members na ito ay mga column members ng corner columns. Since we are aiming to solve the corner columns, therefore, lahat ng mga corner columns lang yung kinuha dito. So, every corner column members ay may mga summary, which is yung max fy, minimum fy, max mx, minimum mx, max mz, minimum mz. So, this is for the second floor na naman, and then the third floor. Ito. Third floor, and then fourth floor. So, lahat ng mga column members na ito ay uh, for the corner columns. And then after is um, gagawa tayo ng summary, which is for the kukuha tayo ng pinaka-maximum na FY para sa lahat ng mga floor level ko- sa building. So for the ground floor, sa mga corner columns members. So for the ground floor is 84.665, 95.576, 70.846, and then 45.229 for the fourth floor. Since yung pinakamalaki is si 95.576, therefore, nasa second floor yung mag-govern na pinakamalaki na may pinakamalaking FY, which is si 95.576. And for the maximum MX, sa lahat na nandito, yung pinakamalaki is si 0.182, which is si beam 305. For the maximum FY is si beam 336. For the maximum MZ is si 304.795. Siya may pinakamalaking value ng MZ from ground floor to fourth floor. Therefore, um, siya ay from beam 136. So, for example, dito kay FY is nasa second floor siya. So, siya si beam 336. So, second floor, nandito yung summary ng second floor. So, for the second summary ng second floor, 36. So, siya yung may pinakamalaking value ng FY. So, ganito lang po yun. Every column members is my own summary siya, and at the same time, every group, which is may tatlong group yung columns, which is yung corner, exterior, and interior. Sa corner, itong tatlo yung nag-govern. nag-govern, which is for the Fy 95.576, and then for the Mx 0.182, and for the Mz is 304.795. Also, for the exterior, yung may mga pinakamalaking values from ground floor to fourth floor ay nandito makikita sa exterior columns na tabulation summary. So, dito, ang nag-govern sa lahat ng Fy, Mx at Mz from ground floor to fourth floor ay si 127 and 863. Meaning, si 127, yung 863, isang column members lang dapat to. But because may staircase kasi kaming nilagay, so na-divide to yung nalagyan ng midspan na node yung column member. That's why, so girid lang gihapon namo siya as 127 and 863, since in real life isa lang siyang from connection to connection. So siya yung nag-govern sa Fy, Max MX at Max MZ sa lahat ng exterior columns sa aming four-story building. For the interior summary, which is ito, yung mga nag-govern lang for the Fy is si 98.281, for the Mx is 0.182, and for the Mz is si 297.694. Sila lang yung mga nag-govern na value sa Fy, Mx at sa Mz. Therefore, um, na, yan lang din yung mga values na i i-input dito sa for the interior tabulation. So dito siya i-input sa values from staad, which is the x-axis, z-axis, yung maximum Fy niya, for the value from staad, which is values from staad, which is dito makukuha sa interior tabulation. So, since dito, maximum Fy yung kinonsider, so dito naman, maximum Mx. So, kung anong Fy ng maximum Mx is dito, lahat ng yung maximum Mx dito mismo, tapos yung z-axis ng maximum Mx. For the maximum Mz is kung anong Fy ng maximum Mz, and then yung sa x-axis, kung ano yung value ng mga Mx niya, at yung maximum Mz na mga values, which is nandito sa interior pa rin. So dito lang makukuha kung doon sa dito sa third na analysis, which is sa maximum MZ. So ito yun. So ito yung sa Fy niya, Fy values, ito yung sa Mx values niya, which is 0. So same with the exterior. So kung anong value na makikita mo dito, yan din yung i-input mo dito para lang sa exterior columns. And for the corner columns, dito makukuha sa corner tabulations yung mga dapat i-input para sa maximum Fy, maximum Mx, at maximum Mz mo na mga designs. So, dito po sir, maximum Fy, maximum Mx, at maximum Mz na mga designs. So now, let's proceed for the analysis of columns. Overall design for the steel column members. For first is i-identify na mo sir yung mga values na from staad na makuha. So after na ma-run analysis yung staad po sir. So ito po yung max Fy niya na value, yung 95.5760, and then max Mx, which is 0.182, and then yung Fy niya is itong 31.444, and then z-axis niya, mga values niya. And then, sa max MZ, yung Fy niya, 86.665, Mx is equals to 0, Mz is equals to 304.79795. So, ito po sir, sila lahat is considered as yung mga critical beams or column members, yung mga critical column members na subjected sa mga maximum Fx maximum Fy, maximum Mx, at maximum Mz. So, for the maximum Fy, which is 95.5760, ito yung mga corresponding values niya corresponding values ng column member 336. Ito, column member 336. Since, so ito, i-analyze na lang sir if first, check if web and flange are compact. For the flange is BF over 2TF, which is, ito po yung limiting width ratio ng flange ng I shape. So for the BF over 2TF is equals to 3.0091, or according to NSCP AISC table, BF over 2TF is equals to 3.1. For the limiting width ratio for the flange is 0.38 square root of E over Fy, which is considering the flexural members for the flange na nasa NSCP 2015 table. So, according to the limiting width ratio ng flange is 0.38 square root of E over Fy, 9.0837. Since hindi siya nag-exceed sa limiting width ratio ng flange, therefore, compact siya. For the for web, yung web is equals to get the limiting width ratio for the web is h over tw, which is 6.8578. Ito yung value ng h, d minus 2k des. Since h over tw is equals to 6.8578 or equal to 6.89, which is ito yung nasa AISC na table. So for the limiting width ratio ng web is 3.76 yung i-consider, kasi ito na formula is sa flexural members sa NSCP 2015. So, since hindi naman nag-exceed si 6.8578 sa 89.8812, therefore, compact siya. Next is to identify the compute for LB, LP, and LR. Since LB is equals to 3.2, kasi nga po second floor siya, and then yung height ng second floor namin from the ground floor is 3.2, so 3,200 yung column length. So LB is equals to 3.2 meters. And then LP, the limiting, so LP is equals to 1.76 RY square root of E over FY. So, less than siya. Si LB is less than LP. Yung pagkuha ng LR, so ito is nasa NSCP 2015 po ito, sir, which is ito. So, dito kinuha yung values ng LP, which is the 1.76 RY square root of E over FY, and then the LR, which is 1.95 RTS E over 0.7 Fy square root of JC over SXHO square root of 1 plus square root of 1 plus 6.76 times 0.7 Fy SXHO over EJC square. So, ito yung formula for the LR. Since ito yung formula ng LR, so, yung value nito is 44.442. Since hindi nag-exceed si LB sa LP, hindi rin siya nag-exceed sa LR. Therefore, nasa zone 1 lang siya. Nasa zone 1 nasa zone 1 siya, which is LP is greater than LB, which is LB is less than LR. So, dito sa flexural analysis, since zone 1 siya, therefore yung gagamitin is 1. And then, for the MP is equals to Fy times ZX is, ito yung MP niya. So, parang limiting na moment, which is 4,235. Since zone 1 naman siya, so CB is equals to 1. So, hindi magagamit yung formula na CB times itong, hindi magagamit yung formula na ganito. Since hindi mas malaki, since mas maliit si LP kaysa kay, mas maliit si LB kaysa kay LP. So, therefore, ang formula lang dito is Fy times Zx. So, equals lang sila. And then, makukuha mo na yung nominal moment. For the LRFD, or the ultimate moment, which is the times 0.9 VMN. Therefore, the answer is the MU is equals to 3811.3811.5, which is greater than 0.09, so safe. So the remarks is use 14 by 370. So since okay naman siya along x-axis, so um, accept or use it. So, and then next is yung sa MZ axis. So, ito dito sir is so MP is equals to FYZY and 2000 2121 yung FYZY. Since zone 1 lang din siya, so yung value is FYZY pa rin. And then MU is equals to VMN, which is 1908.9 is greater than 171, thus safe din siya. So for the actual analysis is K is equals to 0.65 for the second floor since ano ni siya fixed yung both ends niya. So 0.65 KL over R is equals to 11.5556 and then CC is equals to 4.71 square root of E over FY. So KL over R, so comparing KL over R and CC, hindi naman nag-exceed si KL over R kay CC. Therefore, yung gagamitin na formula is 0.658 para sa FCR is 0.658 square root of raised to Fy over Fe times Fy. So, first is kukunin yung value ng Euler's buckling stress which is pi squared over times E over KL over R squared which is 14,782. Thus, um, yung value ng FCR is 346. And then, makukuha mo na yung nominal load which is Pn is equals to FCR times Ag. So, yung ultimate load is PU is, by the way, PU is equals to VPN. Therefore, yung ultimate load is 21,126 kilonewton. So, which is way greater than 95.576. Thus, safe siya. So, yung remarks is use W14 by 370. So, para sa interaction diagram of axial and flexure, so um, this is according to AISC that this is according to AISC that if PR over PC is greater than or equal to 0.2, thus ito yung gamitin na formula. When PR is less than over PR over PC is less than 0.2, so dito PR over PC greater than or equal to 0.2, so ito yung formula. And when PR over PC is less than 0.2, so ito rin yung formula niya, sir. So, first is, let's evaluate first if ano yung value ng PR over PC. Since PR over PC is equals to 0.0044, which is less than 0.2, therefore, yung gagamitin na formula is ito. So, for the interaction of axial and flexure, or the interaction diagram of axial and flexure, is, ito yung formula according to AISC. So, when PR over PC is greater than or equal to 0.2, you should use this formula. But when PR over PC is less than 0.2, so use this formula. So, this is according to AISC. Since so first is evaluate first kung ano yung value ng PR over PC na ratio. Since PR over PC is equals to 0.0044, thus less than siya sa 0.2, thus ito yung formula na gagamitin. So, ang remarks niya is pass. So, same with, since ito ay sa corner columns, same process lang para sa max Fy. So, ito yung mga values ng x-axis and z-axis. For the max mx, ito yung value ng Fy niya at yung sa mz values niya. And then, last, for the mz maximum MZ value niya, ito yung value ng Fy niya at yung sa Mx niya. Since ito yung sa corner column, so iba rin yung iba rin yung sa groupings ng exterior columns. So for the exterior columns, ito yung mga nag-prevail na mga maximum values, which is 207.941 for the maximum Fy. For the maximum Mx is equals to 13.874. And for the maximum value of z-axis is equals to 356.351. So, ito sila lahat. Itong beam na to, 127. So usually, kasi nga, si 127 and 863, siya yung nag-prevail para sa columns is, so siya yung, ano sir, so dito makikita yung mga value niya. Siya yung nag-prevail. Since siya yung nag-prevail, so pass naman siya. So, okay siya, safe siya, satisfactory siya. For the interior columns is, kinuha ko lahat yung, since kinuha ko na lahat ng mga maximum values ng Fy at Mx at Mz, so, let's see. So, for the interior columns, ito yung mga nag-prevail. Si column number 313, column number 313, si column number 313 for the Fy, column number 313 for the max Mx, and column number 144 for the max Mz. So, ito yung values niya, sir. So, compact, dalawang. So, compact, and then save for the flexure analysis, save for the axial analysis, and then save pass siya sa interaction of axial and flexure. So, same with dito sa max MX, which is compact, save sa flexure analysis, save din sa axial analysis, and then save din sa flexure and axial analysis. And then, so pass, save din siya for the max Fy. So, the save, and then compact. So, again, for the exterior columns, safe din sila lahat. Lahat sila ay pass para sa interaction of axial and, so, kasi lahat sila, compact naman sila lahat. And then, next for the flexure analysis, lahat sila ay safe along x-axis, mx and mz. So, lahat naman sila ay safe. For the axial analysis, lahat sila ay safe. Tapos, sa interaction of axial and flexure, lahat sila ay nag-pass, which is less than sila sa less than itong values na ito sa 1. So, ito yung checking ng columns po, sir. So, according to our STAAD, so what we use also is 14 by 370, 14 by 370, which is also same sa ginamit namin para sa aming columns, which is 14 by 370. After, sir, is, so since na-check na namin na-check namin dito yung value ay yung LRFD na code ng AISC. So, run analysis ko na lang po, sir, para makita if safe po yung 14 by 370 na columns to carry the loads sa 4 multi-story commercial building po namin, sir. So, wait lang po, sir, ha? Hmm. So, lahat sila ay zero errors and zero warnings. Thus, para makita yung if nag-fail yung column members ko po, sir, so dito siya makikita sa analysis output. Since yung sa analysis output po, sir, is So, dito po, sir. Wait lang po, sir. For the steel design, so lahat sila nag-pass. But, to ensure if lahat talaga nag-pass, so I will search fail para sa steel design na LRFD. So, since zero matches po siya, so meaning po, sir, is walang columns na nag-fail, so lahat ay safe. I think that's all po, sir, for the column analysis. Thank you, sir.
Design-based shear. So, for the seismic design for buildings, importante nga makuha na to ang value sa base shear para ma-estimate na to ang maximum expected lateral force on the base of the structure due to seismic activity. And after na mo mastada nga mo ang structure and based sa result is nag-generate siya og base shear nga 4,841.23 along x direction and 4,000 ano to? 4,626.70 kilonewton along z direction. So, kailangan siya i-check sa Excel program kung ni coincide siya sa result sa staad, from staad. So, there is sa among Excel in designing the base shear is nagkuha me first of seismic weights every frame along horizontal axis and vertical axis. So, after makuha ang all of the weights from second floor to roof deck, so, amo siya i-input diri sa main nga Excel program for the base shear. So for the preliminary data is kailangan makuha ang total weight from roof deck to second floor. For the frame A is naa siya 35,700.350 kilonewton. So since ang structure is naka-base siya here in Mindanao, so ang iyahang zone factor is at zone 4. So kaning values na nandiri sa seismic zone, occupancy category, seismic source type is makuha ni siya sa NSCP 2015 diri nga mga table for the table 208-5 for the near source factor, the NA, for the CA, NV, CV, and so on and so forth. So, dali lang na siya tanan sa 2015 makuha. Then, after makuha ang mga values, is automatic na siya nga solve o design-based shear for para ma-solve ang Vmax and Vmin. Pero dapat ang shear nga makuha is dapat dili siya mo exceed sa maximum shear og di pod siya dapat less than sa minimum shear. So after ma-input ang weight total is automatic na siya mohatag og values for Vmax, Vmin, and for V. Then and so for example for our frame A is nag-generate siya og base shear nga 4,620.45 kilonewton. So i-compare namo siya sa result sa staad. So since frame A is along vertical axis, kung sa staad is naka z-axis na siya. So i-check lang nato kung ni coincide siya or hapit-hapit lang or basing ni lapas siya. So here is 4,620.045 kilonewton. So ang base shear nga gihatag sa staad result kay along z direction is 4,626.70. So therefore, um, pasar siya or tama ang tama ang nakuha na mo nga mga values from NSCP and also the summary of seismic waves and the Excel program also. And ginani lang po na mo analyze ang the rest nga mga frame along along horizontal axis and vertical axis. So makita man po na rin na almost nga ang uban values is almost ni coincide sa gihatag na value sa staad o ang uban is natama ra jud pod na sakto. So okay siya. Okay siya sa okay ang design sa Excel for the base shear of our building. And I think that would be all. So steel service loads. The deflections of steel beams are usually limited to certain maximum values, and among the several excellent reasons for deflection limitations is the appearance of structures. So if mag-deflect ang isa, for example, ang beam, makita jud siya. So isa na siya sa reason nga dapat gina-analyze or ginakuha ang deflection o dapat limit lang po ang deflection sa code or for the standard American practice for buildings, limit lang for service live load deflections is approximately L over 360 of the span length. Pero kaning limit sa or kanina maximum limit sa deflection is dili lang kani daghan pag other maximum deflection values. Depende siya sa different loading situations and specifications. So for our proposal, ang gibuhat namo is by framing and by floor and by span. Depende kung asa ang maximum deflection na occur nga span. Kung asa nga span na occur ang maximum deflection rather. So for mo ang Excel is mo siya mo ang Excel. So for frame A, ang frame A na mo dari is mo na siya ang frame or mo na siya ang tong mga beams along horizontal axis. So itong dari ang mga beams along horizontal axis. So makuha na mo ni nga mga values kani sila dari alang po sa staad dari sa post-processing result dari sa displacement. So naa dari itong mga values for the deflection. So after na makuha itong values dira is i-tabulate na mo siya o ang i-analyze ang dyan na mo is nga itong na ay pinakadako na deflection. So for the frame A second floor is among maximum deflection is nag-occur sa span ng 5 meters. So the limiting deflection from UBS 2009 is just L over 360, so nakay length na 5. So 5 over 360 is 5 over 360 is equals to 13.8. So dapat ang values na mo sa deflection is dili siya mag-exceed sa limiting deflection value. So sa amo ang critical na beam is ang positive value niya sa ang value niya sa positive deflection is 0.7 and then for the negative is 1.123. So ang nag-prevail is si negative na deflection. So since mas less than man siya kaysa maximum nga deflection na 13.8, so ang iyang analysis is safe siya. So, ginani lang po namo for the frame B. Sa frame B, ang pinaka-dakong deflection is na occur sa 5 meter. For the frame C second floor, 6 meters na occur ang iyang dako na parang max deflection. So, since mas man siya, mas less than siya sa maximum deflection value, so safe ang structure. Safe ang beam. Same sa frame D, second floor. Safe gyapon siya. So, mo ni siya ang hinani lang namo pag kuha ang deflection per floor. Sa horizontal axis pa lang ni siya. Then, nagkuha po mi para sa vertical axis. Then, same procedure, kuha muna mo siya, gikuha na mo ang mga values sa staad. From second floor to roof deck. So, tanan is non-safe. So, safe ang amo ang structure for deflection.
Now let's go for our connection design. Right after we determine the section members for our column and the section members for our beam, the next thing we have to do is to connect the both of them. So engineers, or we are tasked to determine the bolts that will be used and the welds that will be needed and the plates that will be used in that connection. So in determining connection design, we use the RAM connection pre-installed in the STAAD Connect. First, we already run and analyzed the design, and we have to ensure that it doesn't have any errors and warnings, and there should be no fails that will be available in our output. So to ensure that, we have to find the fail. So the result is 0 matches, so it ensures us, or it assures us that our section that we used in designing our project does not fail. So next we go to the connection design. But right before we go for the technicalities in our connection design, first we have to show you the connection plan. So for our first floor, there is a beam in our elevator part. This is an elevator part here, and this is our stairs part. So we installed a floor beam so that the load will be lessened. Beam and girder connection. So since we used floor beam for reinforcement to carry loads for the elevator and the stairs, there is a beam and girder connection. So according to STAAD, it is identified by STAAD and it is obviously a beam girder connection. So there is a different connection between beam and girder considering the size of the two members. So since the design of the beam and girder connection result in first in the frame or the second floor frame is almost the same. So let's see and verify it for the start. This is the beam and girder connection for the whole structure. And for the first floor, I think there is 10, 6, 7. So there is a very small difference in their ratio. So we choose the most critical ratio for the beam and girder design, using the most highest ratio in every floor. So the next floor, the second floor, is the same for the B2 and G2 design. They say we use the highest ratio, the highest safe ratio, and then base the design of it. So on with the third and the fourth. We go to the beam and girder details. We noticed that the beam and girder details of the BG connection is almost the same, and they uses the same plates, they uses the same distance. However, we cannot generalize the design of the beam girder connection because of the difference of the section used in every floor. That's why we have three different beam girder design for our project. So after the beam to girder design connection or connection design, let's go to our beam to column flange connection. Now, according to our STAAD, the beam, column, and flange connection, first we have to determine where the column I section has been positioned for us to know where the flange and the web connection takes place. So first we have to use this. Now this frame, it says, STAAD says that this frame will be the beam and column flange connection. This is already designed because my laptop would crash if I will show you the design process. However, this is already designed, this already passed the STAAD connection design. So here in our CAD or the AutoCAD for the connection plan for our second floor, the BCF2 would stand for the beam column flange connection for the second floor. So everything in here will be in a BCF2 for the second floor, because in designing in RAM connection, we noticed that there is a small difference in their ratio. And we noticed that every section or the connection design in every section is just the same. So what we did is choose the most critical or the highest value of ratio, so that so that um, the remaining or the rest of the ratio still passed, but we have to uniformly design it for the simplicity of the design. So the design will be different for the second floor, the third floor, the fourth floor, and the roof deck BCF connection design. Um, Although uh, I have to show you the similarity of the design for the second. This is the connection plan for the second floor, the third floor connection plan, the fourth floor connection plan, fourth floor connection plan, and the roof deck connection plan. I have to show you the beam and column flange connection, wherein there is the same beam and column flange connection for the second floor, the third floor, and the fourth floor. However, the including the plate used, the distance, and the bolt usage, which is the bolt is in 3 bolts used for a at 20 mm in a 325 newton bolts. So there we noticed that the second floor, the third floor, and the fourth floor have the same connection design. However, they vary in member connection, which is the column and the web section connection. They vary in that part, so that we cannot. So we designed the second floor, the third floor, and the fourth floor, and the roof deck differently. However, we notice in this part that the roof deck have only 2 bolts at 20 mm in a 325 newton bolt. Maybe because the roof deck doesn't really carry much load compared to the ground floors or the preceding down floors. Now we're through with our beam column flange connection. So if there is a beam column flange connection, then it is understandable that there is a beam and column web connection. Note, if you read this, there is a welded connection, beam and column flange connection, and a beam column web connection, is all welded because it is the only connection that will resist the moment in each intersections. So it's safe to say that bolts connection resisting shear for in every intersections. So we'll go to our beam and column web connection. So it is welded connection, and here is the plan for the beam and column beam and web connection. This part of the framing will be the beam and column web connection. We have to check it in our STAAD to verify the position of the beam and column web connection. So yes, the beam and column web connection is in that direction. It passes our using the clip angle and a weld connection for our moment, clip angle for our shear. It passes it all beams, and the same principle has been used in every floor. We use the most critical ratio to design the connection in every floor. For the simplicity of the design, and up to the upper floor. So we'll go here for the details of our beam and column web connection. Yes, it is the same. They have the same bolts used, the same number of volts, the same diameter of bolts, which is 20 mm, a 325 Newton bolt used. With the same principle, they have the different sections, so we cannot um, design it through upper floor. So we design it per floor. So that is our beam and column web connection. So that is the only connection that's available, or we can use in connecting uh, our sections that is known to us. For the conclusion, the steel properties we use for our beams and columns for our four-story commercial building are W14 by 370 for our columns, W12 by 109 for our second floor frame beams, W12 by 87 for third floor beams, and W12 by 65 for our fourth floor beam. We use W12 by 45 for floor beam and W12 by 45 for our roof deck. All of these steel section that we used has passed both the AISC 2010 Unified Code and LRFD method in STAAD and Excel program using 2010 and 2015 NSCP provision. That would be all. Thank you and Merry Christmas, sir. Merry Christmas!